Okay, so hi everyone, my name's Alex, and this is another OSI model video. Sorry, let me pick up the microphone. And I haven't done one in a while, but I thought I'd start doing YouTube videos again because I've had a break and doing other things like making apps and learning JavaScript and CSS. So I thought I'd start again by making YouTube videos and hopefully helping people learn various things. And today, this video is going to be about the network layer, which is inside of the OSI model and is the third layer. So let's get started. So the first part I'm going to describe is the functions of the network layer. So there's three main functions which I'm going to talk about. So the one function of the network layer, hardware and software, is to efficiently handle the incoming packets and then decide their destination and then choose which route is best to them to get them to their destination. So say if you've got like a request from a server or a network that's in another country, then packets are going to go to your network. The function of the network layer is to handle those incoming packets, and then once they get to your network, the network layer will help decide where they want to go, and will also decide how they mean to get there, to get to their destination. So what is the most efficient way? Instead of finding out, just throwing it out there, it'll search quickly what is the best way, like what is the best route for this. Is it this network? Is it over across this internet connection? It will handle the incoming packets, decide their destination, and then choose which route is best for them to take to get to the destination. Another function of the network layer is to encapsulate messages. So encapsulating messages is also a role of the network layer. It takes these messages from the layers which are higher up and then places them into datagrams, which are known as packets, which are tiny bundles of information, and it assigns them a network layer header. So the third function of the network layer is logical addressing. Now, this is probably the most important one. So logical addressing is the one integral part of the network layer, as it allows a person to assign an individual address to a device on their own network, and it lets you access it by using the address. The logical addresses are created and used by the protocols such as IP, so Internet Protocol, and I'll discuss that in the next slide. So the logical addressing is very important because it allows you to uniquely identify your device on a network, so the devices are able to talk to each other. So this IP address of this router or this IP address of this modem, so they're able to communicate with each other, so then the IP address. So the network layer is also used to translate the logical address to a MAC address. So let's go on to the next slide. So protocols. So one main protocol found in the network layer is the Internet Protocol, which I discussed earlier. So which is used to specify the format and shaping of packets, which are tiny bundles of information, and it is used in conjunction with the TCP protocol, so data is able to be sent from source to recipient. Now in the network layer, it isn't used in conjunction with the TCP, IP, and there's another protocol called NetWare. I think NetWare 205.11 or something like that, which isn't really much worth talking about really. The Internet Protocol is the main one because it shapes and specify the format in which the packets will be travelled in. So without TCP, the IP is able to send data, but there is no link between the sender and the receiver. So what I'm guessing this is, because I've researched this and I got a bit confused, but I'll put a link into the websites that I visited, so hopefully you can make your own assumptions about it, is that the IP is able to send the data to the recipient, but it hasn't got like a logical link, so it might take longer. But with TCP, since it creates that sort of bridge between the sender and receiver, it makes the connection and sending of the packets much smoother than if the TCP wasn't there. Networking is very theoretical and it goes deeper than a lot of IT subjects. So the next thing I want to talk about is packet forwarding. So packet forwarding is the relaying of packets from a network entity to another by the use of nodes. So this could be from a router to another router, or from a modem or whatnot. And so the most simple is unicasting, where there is only one sender and one receiver over the network. Below, unicast is shown, which sends messages to one network destination, which is known by unique address. So as you can see, there's 6 sort of nodes here, and we've got one sender with the arrow, although it's a very crappy drawing. We've got one sender and then one receiver, even though we have 6 sort of nodes on the network. Now this is unicast, and unicast there's only one sender and one receiver, whereas if this was broadcast, in broadcast there's one sender and it sends to every single node on the network. Now we're not looking for that really, unless, well, in this slideshow we're not. I'm just going to show you unicast, but broadcast is when you have one node sender and it sends to every single node on the network. So the last way, the extras, for the extras I just thought I'd explain just like a glossary and explain what words are, what they mean. So routers are devices which sits between a modem and a computer and transfers information from the modem to the computer. Bridges. A bridge is used to connect one LAN to another as well as pass on messages between the networks. Firewalls. They are software/hardware which is used to stop unauthorized access into your computer. Switches. Switches are used to filter and then forward packets across LAN compartments. LAN is local area network, I think. Yes, it is. It's a very small network. And a MAC address stands for Media Access Control and is an address on a piece of hardware to uniquely identify it on a network and is found on the network interface card. So almost really, the MAC address is almost as important, or if not more important, than the IP address, because the IP address is used to establish an internet connection. So if you're not connecting to the internet, you don't really need an IP address. But if you want to identify a computer, the actual device, then you'll need the MAC address. And I think there's a way of identifying the MAC address on the computer. I think you have to go into the command prompt and type in ipconfig, or don't trust me on don't type in anything I just said, because I don't. With the command prompt, you can delete the whole hard drive, and I don't want someone to do that just because of what I've said. But I'll go back to the start. I know I've been a bit mumbly because I haven't done this in a while, and plus, it's not the easiest subject to talk about, really. Network layers. I mean, majority of people don't even know what network layers are. But I know a bit about it. I like to think. But so the functions, so logical addressing, encapsulated messages, and then make sure that the packets handles incoming packets, chooses the packet's destination, and then chooses how those packets get to the destination. So the protocol is the IP protocol is used in the network layer 3. Packet forwarding is also used, so that's the relaying of packets from network entity to another. One example is unicast, where there's one sender and one receiver. And extra, so routers, bridges, firewalls, switches, and MAC addresses. So that's it for today. I'm sorry the video's a bit longer. I'm sorry it's not as high quality as it, well, not as it normally is. It's just, not that my videos are high quality anyway, but not that the video is high quality. But I just think there's not really that much information on the internet that's in layman's terms. A lot of the things on the internet are information that's due for people that have already had some network experience. But if you just want to know what a layer 3 address is, or network layer 3 of the OSI model is, I hope my videos offer a more simplistic explanation, because I'm not that intelligent. So I'd like to think I can help people that are on the same level as me. So yeah, thanks for watching. See ya. Bye.